Hello everyone, welcome to GATE lecture series of SA Engineering College. Myself Srimathy, Department of EEE, and this is our GATE syllabus. And today I will discuss about the DC motor characteristic. And this is my outline: torque speed equation, torque armature current characteristic, speed armature current characteristic, torque and speed characteristic and application, and some problem based on the DC motor. And before I start to characteristic of DC motor, just I recall about torque and speed equation. So first one is the torque equation. So T directly proportional to phi Ia. The phi is nothing but is a produced flux and Ia is the armature current. So in DC motor, the produced flux is always directly proportional to the field current. So I rewrite the equation in T directly proportional to Ia If. That means in DC motor, the produced torque is directly proportional to product of armature current and field current. Okay, so the finally torque equation T directly proportional to Ia into If. And second one is the speed equation. So we already know about that back EMF. So the back EMF formula EB equal to NP phi Z divided by 60A. So EB is nothing but is a back EMF and N is a speed and P is a pole and phi is a flux and Z is a conductors, number of conductors, and A is a parallel path. In this equation, P is at 60A is a constant term, so we have to neglect that and rewrite the equation EB directly proportional to phi N. So phi means flux, N means speed, but I needed only for speed, so I rewrite the equation N directly proportional to EB divided by phi. And next one, the voltage equation V equal to EB plus IA RA. EB means back EMF, IA means armature current, and RA means armature resistance. Okay, so EB equal to V minus IA. I needed only for back EMF, EB equal to V minus IA. So substitute the back EMF in above equation number 1. So I rewrite the equation N directly proportional to V minus IA RA divided by phi. So already I told that DC motor, the produced flux is directly proportional to field current. So I rewrite the equation N directly proportional to V minus IA RA divided by field current. This is our speed equation. And next one is the characteristic of DC motor. Usually the characteristic of motor separated in two types. First one is the electrical characteristic, another one is the mechanical characteristic. So these torque versus armature current and speed versus armature current. These two characteristics is the electrical characteristic and torque versus speed is a mechanical characteristic. And first one is the DC shunt motor, torque versus armature current characteristic. In DC shunt motor, the field current is a constant, so the field current is equal to the flux, so the flux is also constant. Already we know very well the torque equation, T directly proportional to armature current and field current. The field current is a constant, so we have to neglect that, and finally we get the torque equation T directly proportional to Ia. That means whenever the torque is increased, the armature current is also increased. So these characteristic curve shown in figure. So whenever the armature current is increased, the torque is also increased. So the curve is linear manner. And second one is the speed versus armature current characteristic. The speed equation N directly proportional to EB divided by phi. So N directly proportional to EB divided by 5. This is our speed equation. We know very well for back EMF. So the back EMF formula V minus IARA. So V minus IARA divided by flux. So the flux is the constant, so we have to neglect that, and finally we get N directly proportional to V minus IRA. This is our speed equation. So whenever the speed is decreased, the armature current is increased. And next one is the torque speed characteristic of DC motor. So DC shunt motor torque speed characteristic, just assume that whenever the load, the motor is operated under the no load condition, the torque will be produced. The produced torque is denoted in TA0, that is no load torque, and as motor is rotated under the no load speed. So the no load speed is denoted N0. Whenever the load is increased, the torque requirement is also increased, but the speed of the motor is decreased. So only the DC shunt motor is operated under the constant speed application. So this is the characteristic curve of DC shunt motor, speed torque characteristic curve. This is the increase the load in DC shunt motor under the no load condition. So the generated torque is denoted TA0, no load torque, and then speed is no load speed N0. At the time the speed of the motor is slightly decreased in practical cases. Some of the application is a constant speed. And this is the application of DC shunt motor. This lathe machine, drilling machine, milling machine and paper machines, these are the application of DC shunt motor. And next one is the DC series motor, torque versus armature current characteristic. So the torque equation, T directly proportional to IA into IF. So in DC motor, the field, armature and load is connected in series manner. So field current is equal to the armature current. So I rewrite the equation, torque directly proportional to IA into IA. So that means torque directly proportional to the square of armature current. In this characteristic curve, we have to separate it in two types. First one is the before saturation period and another one is the after saturation period. So in this period, the generated torque directly proportional to the square of armature current, and after saturation period means the generated torque directly proportional to square of generated torque directly proportional to only for armature current, not a square of armature current. And another one is the speed versus armature current characteristic. So already I told that the field current is equal to the armature current. So the speed equation N directly proportional to V minus IARA minus ISRS. This is shunt current and shunt resistance. In this cases, the speed will be increased, but the speed will be decreased, the armature current will be increased. And next one is the speed torque characteristic of DC series motor. In this cases, it's a combination of before two, that means torque and armature and speed and armature. That means whenever the speed is decreased, the torque of motor is increased. And then application of DC series motor, electric train, diesel electric locomotives and cranes and conveyors, these are the application of DC series motor. And torque and armature current characteristic. It's a combination of three motors, that means series, shunt and compound motor. The first one is the series and this one is the series motor and shunt motor. And next, speed and armature current characteristic. So this is a series motor and this one is a shunt motor. And then problem, a DC motor takes an armature current of 110 amps at 480 volt. The armature circuit resistance 0.2 ohm. The machine is a 6 poles and the armature is lap connected with 864 conductor. The flux per pole is 0.05 and calculate the speed and cross torque. So the given data is armature current IA equal to 110 amps and armature voltage V equal to 480 and armature resistance RA equal to 0.2 ohm and number of poles P equal to 6 and number of conductors Z equal to 864 and flux per pole phi equal to 0.05 and then type of winding is a lag connected. So first we have to calculate the speed of the motor before I calculate the back EMF. So the back EMF formula EB equal to V minus IRA. Already we know very well voltage, and armature resistance and armature current value. Substitute all this value and finally we get EB equal to 458 volt and calculate the speed in RPM. So the formula of back EMF EB equal to P phi Zn divided by 60A. And P is the number of poles, phi is the flux per pole and Z is the total number of conductor, N is the speed in RPM, A is the number of parallel path, it's a lap winding, so A equal to P and we needed only for speed, so N equal to EB into 60 into A divided by P phi Z. So substitute all the value and finally we get speed 636.11 RPM. And second one is the cross torque. So the cross torque developed by the motor is equation is P mechanical power equal to T into omega. So we needed for the speed in radian per second. So the formula is omega equal to 2 pi n divided by 60 and substituting the n value in above equation finally we get speed in radian per second 66.66 radian per second. And but I needed for the torque. So the mechanical power we have to calculate that and find mechanical power equation EB into IA. So the back EMF and armature current and substitute the value and finally we get mechanical power 50,380 watts and I needed only for torque. So T equal to P mechanical power divided by omega. Substitute all this value and finally get torque 755.85. And second problem, which of the following torque and armature current characteristic of DC series motor? So we will shown in 4 curve, but is only one is a DC series motor curve. So this one is the correct answer because in DC series motor the characteristic curve is separated into 2 types, before saturation and after saturation. It's a parabolic curve. So this one is the correct. So this is the combination of torque current characteristic and speed current characteristic of motor. And thank you students, we will see the next class. Thank you.